Oh, wait. All right. Ready?
Yeah, let's go.
All right. Hi, everyone. My name's Alan.
My name is Ken.
We're going to be talking about our project this semester, which is analyzing American football data using vision language models. So, just a quick motivation behind why we chose this topic. The sports world in general, and especially American football, it's like very complex. There's a lot of things that are going on the field, and there's a lot of different data that can go into this, including like sort of the plays, the actual plays, and also like just stats and things that they have. So we think there's like a lot of data in this, and there's also, a lot of data collectors like the AW Next Stat and Pro Football Focus, like they have different analysis of the things that can make for very interesting sort of models and projects that we can work on. So this is sort of why we decided to do this, and we wanted to test like modern state-of-the-art vision language models ability to perform on these on the field of American football. The goal, we wanted to train and evaluate a vision language model. In this case, we did the Quinn VL 2.5 on football video data. We want to be able to sort of measure this vision language model's ability to perform on multiple choice questions or open-ended questions related to videos to see if it's able to comprehend sort of what's going on in the videos. And then maybe further on, if we can pre-train a large vision language model, we can fine-tune it to perform downstream tasks. So first we started testing with the pixel rec data set on the Quinn VL. This is just a data set of images, and we sort of continuously pre-train and also fine-tune for more downstream tasks. We just wanted to get familiar with using the vision language model and want to see if the performance actually increases from zero shot to after pre-training to after supervised fine-tuning. And we were able to get sort of the increase in performance. And the actual sport data set we used was a Sport U data set, which contains American football videos of like short little clips, which we broke into frames, and also questions that are related to each of these videos. So what we did was we organized these data into and the questions into sort of these JSON files that are understandable by QuinnVL. So we have like the user role, the pixels, the frames, and also what the assistant message should have outputted. So based on these two, we can output or we can sort of train and or fine tune on this data set to like and you can sort of see like the train loss graph there to like decrease the train loss on the assistant message. Basically, you mask out everything other than assistant message and you just compute the loss on that. Uh, yeah, and then we also for the bigger models we used LoRa fine tuning so that we didn't get like out of memory issues. But yeah, in general, we just process the data and then train it on the vision language model.
Okay, thank you, Alan. So now onto the evaluation methodology. We basically separated evaluate on the MENS MC, which is multiple choice, and OE, which is open-ended data. So we first distinguish between MC and OE data based on the labels, and we use the regular expression package in Python to extract answers if it is MC question. Additionally, our eval and test set contains only American football data set. And for MC data, we actually use the metrics of accuracy to evaluate MC data. And for OE data, we use the evaluation metrics of blue to evaluate it. And we get some pretty interesting results. So the first training SFT we actually done is we do a multi-domain training, which we train on different sports videos, including baseball, badminton, basketball, American football, and then we only evaluate on American football dataset. And without open-ended and MC distinguisher, meaning that we didn't put a distinguisher that shows the prompt that this is MC or open-ended data, and we get a blue of around improvement from 0.13 to 0.30, and the accuracy improvement is from 0.64 to 0.87. And with the OE and MC distinguisher, we actually get some better result, which the blue improved from 0.15 to 0.32, and the accuracy improved from 0.78 to 0.92. And interestingly, we saw that after using the distinguisher, we have all of these metrics starting from a relatively high value and ending at a relatively high value. Yeah, and then Secondly, we also do a training with American football data specifically. So what we did is basically we doubled the data of open-ended question by turning an MC data into an open-ended question and also an MC question. So for turning it into an open-ended question, we simply transform it, strip out the actual answer, and then make it an open-ended question. And then we saw this is the result we get from training on this specific data, which the valid accuracy are shown in a graph for a 32B Quinn 2.5 VL model and a 7B Quinn 2.5 VL model. And we saw the increase is generally the same, but one 32B model rises quickly from a value of zero point 0.7 to a value of zero point 0.9. And then we also saw similar result for blue, but in this time, 32B model actually performs better than the 7B model, which it eventually rises to some value of 0.3A, and the 7B model only rises to a value of almost zero point 0.3. But they all started pretty low from a value of around zero point 0.1. Yeah, and so we want to talk about the challenges and lessons that we learned throughout this project. So the challenges we have is that the Sport U videos are a relatively small data size because we only have around 300-ish training videos, even if we include all of the sport domains. So the data size is a problem that we suspect that model will not be able to learn enough details or knowledge of the sports or we are interested in. And also the video frame selections are pretty interesting since if we want to select more video frames, the memory is going to go out of issues because videos are relatively large size with large pixel size in each frames. So we have to have some kind of trade-off between a memory versus precision issue. And the lessons we learned throughout this project is generally that we first learn the mechanics and how to use VLMs. And secondly, we actually learn the general idea or the sequence of from continuous pre-training to a supervised fine-tuning. And we saw the rises of the evaluation metrics. And this process, we actually learn the systematically how to do this in a systematic way guided by our professor. And then third, we actually learned how to use distributed training and model parallelism because we did face a lot of issues of OOM and we solved them by learning different techniques such as using deep speed, different versions of deep speed. Yeah. And then, so in conclusion and the future works, we conclude that Coin 2.5 VL was able to learn football plays and details from football videos by we saw seeing the increase of valuation metrics of blue value and accuracy in both of these metrics. We also want to consider in the future multi-model time series data, which we saw in NFL data ball. There's like the GPS location of the players. We might think how to incorporate these metrics and data into a multi-model time series data. And then we also want to incorporate frame sampling techniques to improve efficiency because right now we're just sampling the first few frames, first 10 or 20 frames to train. But these frames might not be the most important or relevant frames to training the model. So we might want to look into future techniques of how different frame sampling techniques could improve the efficiency. And we also want to hand label NFL data to increase the data size because the data size we already talked about is really a problem since we think the model couldn't really learn a lot from small data size. Yeah, and that's all. Thank you. Thanks a lot.
Thank you.
Thank you.